In this video, we're going to be asked to sketch the picture of f prime if given f, and construct the picture of f double prime if I give you f prime or if I give you f. That is the video for today. So let's look at the objective. Given a function f, sketch. Let me go ahead and change that word here. I'm not too fond of the word draw. Let's sketch, because sketch is a rough picture of f prime. Given f prime, sketch the picture of f double prime, or I might give you the picture of f and ask you to sketch the picture of f double prime. So what are the prerequisites? What is it that you need in order to find the pictures of f prime or f double prime? Well, you need to recall that extrema, for those of you that do not recall, are max or mins of f are critical points, and critical points are special because critical points is where f prime of x is equal to 0. So that's what critical points are. You also need to know that as we read a graph from left to right, okay, if it goes down, we say that the function is decreasing. As I read it from left to right and it's going up, we say that the function is increasing. So this is decreasing. That means that f prime is less than 0. That's defined in another video. And this one, we say that this one is increasing, or f prime is greater than 0. So these three things you have to understand in order to sketch the picture of f prime if I give you f. So what's the strategy? All right, let's look at the steps. I wrote them down here. The first thing is to find the critical points of f. In other words, find the spots where f has slope of 0. All right. Now you're going to sketch dots on the x-axis at the x values of the critical points. So what I'm saying is, if this is a critical point right here, if this is a critical point, I'm going to ask you to sketch a dot there on the x-axis. This is a critical point. I'm going to ask you to graph a point on the x-axis. All right. Now between each interval, so now that I have the x-axis, and if that was a number line, I have 3 intervals. This is my first interval right here, my first interval, this is my second interval, and then I have my third interval. If the graph is increasing, then the picture of f prime should be above the x-axis. If f is decreasing, then the picture of f prime should be below the x-axis. All right, so what I'm saying here is my picture here is increasing, so that means that f prime is going to be above. So that means it's going to be above. And right here, Mr. Quintana, I'm noticing that my function is decreasing right here, so that means that my f is going to be below the x-axis. And then finally, on the last interval, my function is increasing, so that means that f prime should be above the x-axis. So this is the picture of f prime. Now, the end behavior is very important. Okay, so if you notice, this picture is going up, or we can say that this picture can go back to 0 like this, depending on the end behavior of f. And what it says here, if it's getting steeper, then f prime is going to go to infinity or negative infinity. If it's getting flatter as I go to my ends, that means that f prime is approaching the x-axis, because my slope at the ends are going to be 0, and 0 is found on the x-axis. What do I mean found on the x-axis? Well, you're used to sketching this is x and this is f of x. But when we sketch f prime, this will be x, and now the y-axis is going to be considered the f prime axis. All right, so these numbers here are positive and these numbers here are negative, and what do we find right in the middle? We find 0. So that means that my slope will be 0 on the x-axis. All right, so let's try some examples. On this case, I'm going to give you the picture of f, and I want you to sketch for me the picture of f prime. So I find my critical point. Here's my critical point, and here's another critical point. They're the extrema. So I go up, I put a dot right there. I go down, I put a dot right there. And now what I have to do is I have to check between them. So what is my function doing from there to there? My function is increasing. That means that my function is going, now remember, they got to connect. So I'm going to start here, and I'm going to go up here. And some students are going to say, hey sir, how high do you go? Well, that's why I changed the word from draw to sketch. Sketch is a más o menos, close. It could go higher, it could go lower, we don't know, okay? Now, let's look at another piece of the graph. Let's look at the graph on this side. What's my function doing? My function is decreasing everywhere on that graph. Now, as I go further down here, and my end behavior is getting steeper. So that means that my f prime is going to go down to negative infinity. All right, let's look at one more interval. The last interval is going to be over here. As I read from left to right, my function is decreasing. That means that my slope is negative. So that means that my picture of f prime has to be below. And as I go further to the left, it's getting steeper. So that means that as I go further to the left, it's going to go down to negative infinity. So this graph right there is the picture of f prime of x. All right. Let's try another one. Okay. On this one here, let me go ahead and start with the right side. As I go right here, I notice that this graph is special because right here I'm going to have an asymptote. And what does an asymptote mean? That there's no graph. So if there's no graph, then there's no slope. So that means that f prime better not have a graph on my asymptote. So I make sure that I sketch on there. Now, what is f doing here? F, as I read it from left to right, that's one of the prerequisites, as I'm going from left to right, it's going up, it's increasing. So that means that f prime has to be above it. Now, let's look at the end behavior. Over here, it's almost becoming flat. And over here is getting steeper. So as I get closer to the asymptote, that means that my graph is going to go to either infinity or negative infinity. But we just finished saying that this function is increasing. So that means that f prime is going to be above the x-axis, but it's going to go to infinity as I get closer and closer to my asymptote. So that means it's going to go up like this. Okay. Now on this side it's flatter. So what does flat mean? It's going to become slope of 0. So that means that as I go to the right this way, it's going to be approaching 0, and 0 is the x-axis. So this is the picture of f prime so far. But I still have another piece. I have this piece over here. Now what can you tell me as I read this graph from left to right? As I read it from left to right, my function is increasing. That means that f prime is going to be above. Now in this end behavior here, it's getting steeper, and over here it's getting flatter. So that means that f prime is going to go like this. And this is the other part of f prime. So that means that my f prime picture is going to look like this. Now you're saying, but sir, what about on this side? Can it be on top of it? Yeah, sometimes it's possible. Remember that some functions, like e to the x, the derivative of v to the x is e to the x. Okay. Now, what if I gave you f prime and I wanted f double prime? Well, if I gave you f prime and I wanted f double prime, all I have to do is think of, if I give you f, how do I get to f prime? Well, I take the derivative. So what if I gave you f prime? What do you do to it to get f double prime? I do the derivative. So if I do the derivative here and I do the derivative here, that means that I'm doing the exact same thing. So if you look at these 5 steps, these 5 steps are going to be identical to the 5 steps the 5 steps that we did when we did from f to f prime. So we're going to be doing the exact same thing. Okay, so let's go ahead and look at this. This is the picture of f prime, and I want you to sketch the picture of f double prime. So what I'm going to do is I'm going to find the critical point. So let me change the color here. So that guy's a critical point, I put it there, and right here there's my critical point, I put it there. In between it's increasing, so it's going to be above, and right here is decreasing, so it's going to be below, and right here is getting steeper, so it's going to go down to negative infinity. Over here is getting steeper, so it's going to go to negative infinity. So this is the picture of f double prime. Now somebody's going to say, hey sir, that picture and that picture are the same picture. Yes, it's the same picture, but over here the original function was f, and now we're looking for f prime. Here this picture is a picture of f prime, and I want f double prime, so you're going to get the exact same thing. That's why I use the same picture. Okay, now what if I give you f and I want f double prime? There's going to be 2 methods on how to get from f to f double prime. The first method is, of course, to sketch we're gonna go from F to F prime. Then once we have F prime, we're gonna go from F prime to F double prime. So we're gonna be actually doing 2 steps. This here is going to be step 1, and this is gonna be step 2. That's method number 1. Now method number 2, for those of you that understand, really understand F double prime is gonna be dealing with concavity. So I have to find the points of inflection on F, the points of inflection of F, right? And we're going to sketch them on the x-axis. And then we're going to be looking at the concavity between the points of inflection. If it's concave up, we sketch above the x-axis. If it's concave down, we sketch below the x-axis. So I'm going to do the exact same problem, but I'm going to do them using both methods. So here we go. We're going to do method number 1. Method number 1, this is the picture of F, and I want the picture of F double prime. So I'm going to sketch the picture of F prime. So I'm going to go here, that dot goes there, this one goes here, that one goes there. In between it's increasing, so it's going to be above, and then right here is going to go down like this, and you can say, sir, stop using the same graph. Well, I'm sorry. Now what I'm going to do here is I'm going to sketch, now this here is the picture of who? This is the picture of F prime. Now I want the picture of F double prime. That's what I want. So I find that the critical point of this, so my critical point is going to be right here. So I'm going to put that guy there. And now what is F doing from here to here? F is increasing, right? So that means it's going to be above. And what is F doing here? F is decreasing, so that's going to be below. And this is the picture of F double prime. And that's what I wanted. So I can now go in, take my eraser, and I can erase this one because that's not the graph that I want. What do I want? I want the picture of F prime. So now let me go ahead and connect this back up like this. And there it is. That's what I want. That's the F prime. So now let's try method number 2. Method number 2 is to find the points of inflection. So I have to look at points of inflection are going to be where it changes concavity, where it changes from a U shape to an N shape. So right here, Quintana, it is considered to be a U shape, and about right here it starts to change to an N shape. So it's going to be an N shape right there. It's going to be N shape like this. So where did it change concavity? It changed right there. So this is a point. So that's I'm going to put that point right there, and this is concave up, so it's going to be above, and then this is concave down, it's going to be below. And that is the picture of F double prime. So some of you might like method number 2. Some of you is like, no. I like method number 1, which is draw the picture of F prime and then draw the picture of F double prime from F prime. All right? And that concludes the video.